Good morning, Year 7, and hope you've had a wonderful Easter holiday and a lovely break. I'm going to start you off. Can you have a quick go at this starter for me? Please, can you simplify this first expression? Can you find 245 times 67? And can you factorise 8x squared plus 20x? Please pause the video for a minute or two and have a go at those now. Okay, let's go through some answers. I've got to simplify a collection of x terms and numbers. I'm going to combine together my x terms, so I've got x plus 3x take away 2x, which is going to give me 4x take away 2x, which gives me 2x. I've then got plus 2 plus 7, which would give me 9. Take away 9 gives me 0, plus 1 gives me plus 1. So my answer is 2x plus 1. For the second one, I need to find 245 times 67. You could use grid method or column method for this, I do not mind. I'm going to use column method. So I line up my columns. I've then got 7 times 5 is 35. 4 times 7 gives me 28 plus 3 gives me 31. 2 times 7 is 14, 15, 16 is 17. Then looking at my tens column, 5 sixes gives me 30, 4 sixes gives me 24, plus 3 gives me 27, 2 sixes give me 12, plus 2 gives me 14. If I add those all up, I've got 5, 1, 7 plus 7 gives me 14, 1 plus 4 gives me 5, plus 1 gives me 6, and 1. So I was looking for 16,415. And finally, to factorise this expression, I need the highest number that's a multiple that goes into both 8 and 20, which would be 4. X is also present in both of those terms, so x can go on the outside of my bracket. 4x multiplied by 2x would give me 8x squared. And 4x multiplied by what, Adam, will give me 20x. 4x times 5, lovely jubbly. Okay, let's have a look at today's lesson. This is where we're aiming to end up today, solving these linear equations. So as a quick introduction, the word equation comes from the Latin word equation, which means an equalising. This means we can recognise an equation by the equal sign because it comes from this Latin word. Can you pause the video now and spend 1 or 2 minutes linking the correct definition to each of these algebraic expressions or identities or formulae? So link together, for example, p equals 3x plus 4y is a formula. Is this one 3x plus 6? Is that an expression, an identity, an inequality, etc., etc.? Pause the video, write this in your light blue book, rough paper, off you go. Okay, so the answers I was looking for, this second one, 3x plus 6, and this strange 3 equals sign means an identity. So this triple equals sign links it to an identity. The third one, as we just said, coming from the Latin equation, an equation means equalising. It's got an equals in it, so it's an equation. For the fourth one, I've got 3x plus 2, that's got no equals, no equality, no inequality, so that's just an expression. And the inequality has got the inequality sign here, so 3x plus 2 is less than 14 is an inequality. Pause the video for a minute and have a think. What do the following mean? X plus 3, x take away 3, 3x and x divided by 3. Pause the video and have a think. Okay, so x plus 3 means that whatever the value of x is, whether it be 2, 1,000,000, 12, 100,000, we're just adding 3 to it. X take away 3 just means we're subtracting 3 from whatever x is. 3x is just the same as 3 multiplied by x. And x over 3 is the same as x divided by 3. In your light blue books, if x equals 3, can you match the expression on the left-hand side with the answer on the right? Please pause the video for a minute and match them up. Okay, so the answers I was looking for. If x equals 3, x plus 3 is 3 plus 3, which would give me 6. If x equals 3, x take away 3 would give me 0. If x equals 3, 3 times x gives me 3 times 3, which would give me 9. And 3 divided by 3 will give me 1. Okay, can you now pause the video for me for approximately 5 to 10 minutes and see how many of these you can solve using any method you like? Can you work out what each of the values of x is? For example, the first one, 3 plus x is 8. What could x be? In this case, x is going to be 5. Use any method you like, pause the video for 5 or 10 minutes and see how far you can get. Okay, here are the answers. Please check your work. I was looking for 5, 5, 5, 11, 12, 13, 13, etc. You may have noticed you can sort of work backwards to work out what x is for these first ones. For example, 8 is x plus 3. X has got to be 5 because 5 plus 3 will give me 8. What you might have noticed going from 8 onwards is this is much harder to work out what the x value might be. And it gets progressively harder as you go through. So to solve these types of equations, I reckon the best method is the balancing method, and that's what we're going to go through now. In your dark blue books, can you give me the title Solving Equations? Underneath, can you write solve means work out the unknown variable, e.g. x. Pause the video for a minute to write that out for me. Okay, you know how this works. I'm going to go through an example and then you're going to go through an example, so pens down and watching me. If 3 plus x equals 10, we're going to use the balancing method to subtract 3 on both sides to give me just x on this side, and 10 take away 3 gives me what, Rosie? 7, thank you very much. For the second one, I've got x plus 6 equals 11. Note that I've swapped the number and the x around, but that doesn't matter. This time I'm going to use the balancing method to subtract 6 on both sides. So x is going to equal what, Dejan? 5. Brilliant. 11 take away 6 gives me 5. In your dark blue books, please pause the video now and have a go at these questions. Okay, let's go through the answers. This time I need to subtract 5 from each side. So you should have worked out that x equals 5. And this one you need to subtract 11 from each side, which gives me that x equals negative 5. Okay, pause the video and have a go in your light blue books. What is x for each of these equations for me? Pause the video for a minute and have a go at these. Okay, let's go through the answers. For the first one, I need to subtract 3 from both sides, which will give me x equals 5. For the second one, I'm doing the same thing. I'm subtracting 3 from both sides, which means you should have got x equals 4. And for the third one, we're subtracting 3 from both sides, which gives me x equals negative 10. Dark blue books, you know how this works. I'm going to go through an example and then you're going to go through an example. So pens down and watching the board. I've got x take away 6 equals 11. This time, to just get x on its own, I need to add 6 to both sides, because that's the opposite of subtracting 6. 11 plus 6 is going to give me 17. In your dark blue books, can you do this example for me? Pause the video and have a go. Okay, let's go through the answer. This time we needed to add 11 to both sides to get rid of that subtract 11 and to give me just x on its own. So this time x equals 6 plus 11, which equals 17. Interesting. So if we change those numbers around, x still equals 17. You might have been able to predict that. Can you pause the video now for 1 or 2 minutes and have a go at these 4 questions for me in your light blue book? Okay, let's go through some answers. For the first one, you needed to add 3 to both sides, which gives you x equals 10. For the second one, we swap those numbers around, but we need to add 7 to both sides, so x equals 10. For the next one, we need to do the same thing. We still need to add 7 to both sides to give me x on its own, but this time negative 3 plus 7 would give me 4. And for the fourth one, again, we need to add 3 to both sides, but this time we're starting at negative 7. Negative 7 plus 3 would give me negative 4. Can you now pause the video for 5 to 10 minutes and have a go at these questions for me? I've written out a number line to help you out. Feel free to use it. If you're confident you do not need to use it, in your light blue books, have a go at these examples for me now. Okay, let's look at some answers. The answers I was looking for, n was equal to negative 1, negative 5, negative 5, negative 5, negative 1, negative 5, negative 4, negative 5, negative 3. I disagree. That should be positive 3. I've then got negative 7, negative 8, and negative 8. Please check your work and see how you did. Sorry, this one should also be positive 1. Okay, can you now pause the video and spend 5 to 10 minutes working through these questions for me in your light blue books? Okay, here are the answers. Please check how you did. They get a little bit trickier as you move towards these fractional answers, so don't worry if you got lost here, but aim to get questions 1 to 8, 1 to 9 correct. Okay, this was our lesson destination at the beginning of the lesson. Can you pause the video and in your light blue books have a go at these 4 questions and then I'll go through the answers. Okay, for the first one, I've got x plus 12 equals 29. So to get rid of that plus 12, I need to subtract 12 from both sides. Which gives me that x equals what, Brooke? 17. Thanks, Brooke. For the second one, I need to get rid of the negative 7, so I need to add 7 to both sides. Lucy, what's 56 plus 7 for me? 63, thank you very much. This one, I need to get rid of the take away 3, so I need to add 3 to both sides, which will give me x equals what, Daisy? 3, thank you very much. And finally, I've got subtract a third for this one, so I need to add a third to both sides. And Elliot, what's negative 18 plus a third? Negative 17 and 2/3. In your light blue books, please pause the video and have a go at these 4 questions for me now. Okay, you may have noticed these are all variations on a theme. You've got to solve an equation, factorise, calculate a substitution and expand and simplify. The answers I was looking for are now up on the boards. We should have got x equals 1, 2 lots of x plus 4, 14 when you substituted that in. And if you could expand and simplify this double bracket, don't worry if this was too hard for you. This was more of an extension question. You should have got 4x squared plus 32x plus 64. I wasn't expecting everyone to get that one right. Okay, that's the end of the lesson for today. Thank you very much, Year 7, and see you soon.